Traffic control devices play an essential role in highway safety. We'll look at the basic principles of these devices in order to gain a fuller understanding. Our study includes only basic installation and maintenance procedures, not engineering requirements. We'll also study current marking and delineation devices by looking at the purpose of these devices and what affects their performance in the field. Traffic control devices must adhere to set standards so that they achieve a national uniformity. Through a national uniformity, drivers will be able to respond the same way wherever they see the devices. To achieve this uniformity, certain rules and requirements have been established at both the national and state levels. At the national level, the Manual on Uniform Traffic Control Devices is the established standard for all traffic control devices on all street and highways open to public travel. This manual is usually referred to as the MUTCD. I'll refer to it both by the full title and the initials throughout this session. Most states have adopted the Manual on Uniform Traffic Control Devices. However, a few states have their own manuals. The individual manuals of states must be in substantial conformance with the general principles and guidelines of the national manual. It is extremely vital that each state, no matter what manual it uses, has a well-managed traffic control device program. The standard established for traffic control device programs defines the shape, size, and color of the signs. Standards also tell us where to place the devices, both laterally and longitudinally on the highway. These color, shape, and size standards for signs are incorporated by reference in the MUTCD, and the standard alphabets contains layout for the letters and numbers that go on the signs, as well as pavement mark arrows, etc. The MUTCD has a helpful implementation guide, the Traffic Control Devices Handbook, or the TCDH. This handbook has a wealth of information on how to apply the MUTCD. All of these manuals and standards help ensure the uniformity of signs. Signs that are uniform in application and appearance have these 5 benefits, the most important of which is the second on the list: consistent interpretation. Before signs are placed on the roadway, there must be a real and demonstrated traffic control need for that sign. Once a sign is placed, it is very difficult to have it removed, so careful placement is essential. For the sign's message to be read, signs must first get the driver's attention. The time necessary for the driver to respond to the message of the sign is usually provided by one of 2 ways. Either the sign must be large enough so that it can be seen in time to respond, or the sign must be placed well ahead of the needed action. Frequently, the public loses respect for our signs because the original reason for the sign no longer exists, or we have been too conservative in our application of the sign. Here you see a regulatory sign. Now, this type of sign informs the driver of a regulation or operational control that applies to that portion of the highway. There are some basic rules to the designing and installing of signs. Signs should be standard and uniform. The messages on the signs should be simple, easy to read, and easy to understand. The signs should be located so that there is sufficient reaction time. And signs should only be used when they are actually needed for motorist safety and/or navigation. The Manual on Uniform Traffic Control Devices categorizes signs by 3 groups: regulatory signs, warning signs, and guide signs. Here's an example of why uniformity in signs is so important. The public has grown to understand that a red octagon designates stop, even when the legend cannot be read. When those basic principles of shape and color are violated, it is likely that the intended message of the sign will be missed by the public. Motorists driving at highway speeds have only a few seconds to read, comprehend, and react to signs. When a sign is overloaded with messages, drivers aren't able to process all of the information. Now, before we get into details on signing standards and placement, we'll look at a video on sign management produced by the American Traffic Safety Services Association.
Talk to traffic engineers at any level of government about the quality of traffic signs on our city and county roads, and you'll hear a lot of similar concerns. Signs are old and worn out. They've been vandalized, or they've been knocked down. Sometimes the problem is too many signs, making it difficult for drivers to pick out the ones they need. Or the signs are non-standard in size, design, and color. Drivers expect uniformity. A traffic sign has to look like a traffic sign, or it's likely to be ignored. Add to all that the need for new signs in new locations, and it's no wonder that many agencies responsible for traffic safety can't keep up with the demand. It's ironic. In a country with the most sophisticated highway system in the world, we're falling short in an area so basic to traffic safety. In a way, we've brought it on ourselves. We've built roads where higher speeds and increased capacity are part of the plan. Drivers have come to expect large, uniform, easy-to-read signs to guide them on their way. When they leave the major highways, however, drivers often carry these same expectations with them. So when they encounter traffic control devices that are unfamiliar or that have been improperly installed and maintained, they become indecisive, frustrated, and confused. Not a good frame of mind for safe driving. In response, the Federal Highway Administration of the U.S. Department of Transportation has sought to establish national standards for traffic signs through the MUTCD, the Manual on Uniform Traffic Control Devices. Most states and many local transportation agencies have adopted the standards of the MUTCD, but problems remain. Mr. Phil Russell, Chief of the Traffic Control Branch of the Federal Highway Administration.
We find that there's a wide variation in the function, the performance, and the maintenance of these traffic control devices. It just varies pretty much by the jurisdiction, and if we think of states, some states have better programs than others, and the same true with cities and counties. With the cities and counties, there seems to be a pattern where a city or county will have a quite good program and will have well-maintained signs and markings, or they tend not to have a very good program at all. It seems to be those two extremes pretty much. What we find is that, thinking of the interstate system first, but this is true of major roads that are operated by major cities and counties, is that when these roads are built, fine first-class traffic control devices are installed, but after those signs have been in place for 10, 12, or 15 years, it's the nature of these materials that they're no longer reflect at night. They don't appear, you can't read them during the daytime.
Top quality traffic signs have a useful life of 7 to 10 years, but the fact is many will be left in service much longer. As a sign ages, it loses its reflectivity, so while it may appear okay in the daytime, it virtually disappears at night. Such a problem might go unnoticed by drivers who are familiar with the area. They know where the signs are. But what about the visiting driver, or one who drives infrequently? Don't we have the same responsibility to make sure they get the warning and guidance they need? Good street and traffic signs make good business sense too. Products and services can be delivered more efficiently, and customers who can find their way easily in and around area shopping districts are more likely to return. In addition, there's no doubt that well-signed streets can aid and dramatically improve the response times of our emergency services. From an ordinance point of view, non-standard or defective signage is more difficult to enforce. Violators have argued successfully that they were not at fault because signs were not easily seen or understood. We must also face the fact that as our population ages, we'll have more older drivers on the road. Studies show that drivers over 60 need signs that are up to 8 times brighter than those needed by a 20-year-old. The numbers can be intimidating. An Indiana survey of traffic signs on state highways found that 60% were seriously deficient in such important factors as reflectivity, design, size, and placement. And behind all of this looms the issue of liability. Whenever a local agency installs a traffic control device, it makes an implicit agreement to maintain that device in good condition. Failure to do so can expose the agency to huge liability risks.
We know from experience that where cities, counties, or states do not maintain proper inventories, do not make proper routine inspections, then when there are accidents and there are traffic control devices that aren't up to acceptable standards, then they have the liability problem, and people have sued cities, counties, and states a number of times over this situation and have collected where they wouldn't have been able to collect had there been a proper program for the signing.
In a study of its liability exposure due to unsafe road conditions, Pennsylvania's Department of Transportation reported that in 1985, it paid out over $20 million in judgments that were directly related to traffic sign deficiencies. Local government agencies have experienced the same consequences on a smaller scale. Many jurisdictions could have totally re-signed their streets for less money than it cost them to settle one court-awarded judgment. What's the solution? While there's no quick fix, there are ways to begin to solve the many problems related to traffic signs. Many of today's traffic administrators are responding by developing sign management programs, systematic ways of evaluating, upgrading, and maintaining the quality of their traffic signs. Although there are many variations, most sign management programs consist of 3 basic elements. First, an inventory of all signs within the system. Second, an evaluation of the sign's condition. And third, a schedule of routine sign replacement. Tom Hicks, traffic engineer for the state of Maryland, describes some of the benefits of such a program.
A city or a county that has a good signing program would have in my judgment, a large benefit-cost ratio. It would serve the citizens very well in improved safety, in more orderly flow of traffic, in less congestion in certain situations. But by far, the safety is the product that's realized. The community is further protected by being able to show that they have a systematic way of reviewing in the field what they have out there in the way of traffic control devices, of having determined the priority for upgrading them, for maintaining them, of doing things on a systematic basis in line with their available resources, both manpower and dollars.
The first task normally associated with an effective sign maintenance program is to conduct an inventory of all signs presently in the system. There's a wide variety of ways to conduct an inventory, from video logging to manual recording out in the field. Whatever the method, a sign inventory is the best first step an agency can take to begin taking control of its signage problems. As part of the inventory, each sign should be evaluated, judged for conformance to the standards of the state's traffic control manual, or the MUTCD. In addition, transportation officials should conduct nighttime reviews of all traffic control devices on a regular basis.
We emphasize the need for nighttime reviews and looking at these devices at night. There are
Once again, Phil Russell.
What we do with the people we visit with is we go out with these people at state level during the daytime, and we show them pavement markings, we look at pavement markings, we look at signs, and we note the condition of them and the location of them. How do they appear? Can you read them? What do they look like? And then we take measurements with these instruments, and we record those measurements. Then we go out at night with the same people, and we look at the same devices, and we find, of course, how it startles people to say, but that sign looked good during the daytime, and they find it has a reading of 50 or 60 or whatever, which is completely inadequate. And yet, during the day, it looked fine, and at night, you can't see it.
Information provided through inventories and reviews helps traffic managers set priorities and make more effective signage decisions. They can plan how they can best bring their traffic signs up to standard, keeping in mind funding and manpower limitations. That's exactly the approach the city of Bloomington, Indiana used when it undertook a major project of re-signing its streets. Using funding made available through the Federal Highway Administration's Hazard Elimination Program, Bloomington's Streets Department contracted a private firm to perform an inventory and evaluation of all the traffic signs within the city. Traffic control specialist Ralph Merkel describes the project.
We had identified a level of need in our own service area that was very significant. We felt that perhaps 50% of our signage at least was in need of being replaced. This is just something that was beyond the scope of our budget without the boost that these two projects gave us. And frankly, with the amount of work that needed to be done and the fact that you can be more efficient in a large-scale operation, we felt that it would pay everyone to go in and just take everything out and start over again.
Recognizing that the problem was beyond its ability to handle completely in-house, the city contracted the services of a local sign manufacturer. Contracting outside services provided a number of advantages. First, it ensured the timely delivery of materials, enabling the projects to be completed on time and thereby lowering the city's liability exposure. And secondly, by purchasing large quantities of ready-made signs, the city actually lowered its per-sign costs.
The overall re-signing of our city was done in two phases. The first project that was made available to us was to attack the arterial and principal streets within the city. And then the second, later program was for all of our residential secondary streets. Then we stood back and looked at the project overall and how we could most easily geographically divide the work areas up and assign the crews a logical flow of work. And quite simply, we divided the city up into quarters and completed a quarter of the city per work unit, and then proceeded on to another area. The projects allowed us to completely re-sign all of our secondary and arterial streets. We were able to bring all of our signage up to current standards in terms of setbacks, types of material, types of hardware. It's made Bloomington an easier place to drive in, a safer place to drive in.
In addition to the immediate benefits brought about through improved signing, Bloomington's system of sign maintenance and replacement provided the city with a number of long-term advantages as well. Among them, fewer unscheduled maintenance calls that interrupt other duties. Better record keeping. They know exactly what they're spending on materials and labor for sign replacement and can estimate future costs. And most importantly, they're providing better service for the people of Bloomington. Traffic engineer Tom Hicks sees this approach working for other jurisdictions as well.
But a jurisdiction that is behind in its re-signing and maintenance could very well find it to their advantage to simply divide the area up into sections and just take a section at a time and just go through and just sort of wholesaledly replace all of the signs. For one thing, then they'd have a fairly accurate record of what's new and when it was placed, and they know that everything was up to standard as far as night and daytime reflectivity and color and so forth are concerned.
Following this method, signs that were removed from one section would be mounted on a test rack and evaluated. Those judged to have a good amount of useful life remaining would be used in other sections as emergency replacements. Many jurisdictions have used variations of this approach, each adapting its program to meet the demands of public safety against the limitations of public funding. In some cases, that meant replacing stop signs one year and regulatory signs the next. While the details will vary, every successful program contains the same three basic elements: inventories of all signs within the system, evaluations and reviews for compliance with the standards, and following a schedule for routine sign replacement. The program can be as comprehensive as available resources will allow. The important thing is to have a program, one that's aimed at getting deficient signage off the streets. As in Bloomington, Indiana, more and more agencies are turning to the private sector for assistance in their sign management programs. Through contracts, local agencies are taking on projects that previously would have been out of reach. Any operation that requires a substantial investment in manpower and materials is a likely candidate for contracted services. We of the American Traffic Safety Services Association are proud of the role our members have played in the re-signing of Bloomington, Indiana, and hundreds of other communities across the country. And we hope that this kind of cooperation between local governments and private industry will continue as we work together toward improving traffic safety and reducing liability risks. For more information, contact the American Traffic Safety Services Association at 5440 Jefferson Davis Highway, Fredericksburg, Virginia, 22401. Our telephone number is 703-898-5400, or call your local ATSA member.
Effective communication with drivers is the goal of all signs. In striving for effective communication, signs themselves should not become a driving hazard. The location of signs and the placement of signs are also important to their proper functioning. Signs should be placed where the sign supports will not become a hazard to vehicles and in such a position that the clear zone can be maintained. The locations listed here would be ideal because they are either protected or in a location where the sign can't be hit by an errant vehicle. Longitudinal location is important to provide proper recognition, comprehension, and reaction time for signs. For instance, warning signs should be placed far in advance of the hazard, so motorists have time to take proper corrective actions. The Manual on Uniform Traffic Control Devices recommends advanced longitudinal placement of warning signs as a function of speed and the hazard. Regulatory speed limit signs are placed at the beginning of the new speed zone. Guide signs and directional signing should be placed in advance of the needed movement. Lateral placement in relation to the pavement is also important to the legibility of signs. The manual contains lateral placement recommendations for rural conditions, both with and without shoulders, always at least 12 feet from the edge of the roadway, and for urban conditions. You'll notice that the height of the signs in urban areas is not less than 7 feet to the bottom of the sign panel. This is to take into account parked cars and pedestrians near signs. Legibility should be ensured by placing the signs above the parked cars. When advisory speed plates are used, the overall signing assembly should be slightly higher. Signs in rural areas should be placed well off the edge of the pavement, improving the safety performance of the roadside. In these rural areas, there isn't much competition for the driver's attention, and the signs can be made large enough for legibility. To avoid glare reflection of headlights off the sign face, signs should be oriented slightly away from the approaching traffic so that proper reflectivity can be achieved. Overhead signs need to have a minimum of 17-foot clearance to allow trucks and high loads to pass under them safely. Overhead signs should also be oriented downward so that dirt, dust, frost, snow, etc. will not drop onto the sign face. Here you see an urban stop sign mounted at the proper height for visibility over parked cars. Part 6 of the MUTCD contains detailed instructions on signing and traffic control in work and incident management zones. Warning signs and guide signs should be black on orange when they're used in temporary situations. The size of the sign and the size of the letters are very important because the time it takes drivers to react to a sign is directly related to their ability to detect and read the sign in time to react. Drivers in unfamiliar areas at night find minimum-sized street name signs to be a big problem. Now, here you see the recommended letter sizes for street name signs. If these guidelines are followed, drivers will have the proper reaction time for various speeds after reading the sign. Larger letter size street name signs and advanced street name sign can improve operational efficiency and safety. A relatively new sign is now being used. This chevron indicates a sharp change of alignment with the direction of travel. Chevrons should only be used where at least two of them can be seen at any given time. Chevrons are not intended to be used on work zone lane tapers. To function properly, signs should adhere to specific standards. They should be installed at the proper longitudinal location, be the proper size, and contain the proper lettering. Have a standard message or a message that is appropriate for the situation, and be clearly seen. This chart shows why visibility at nighttime is so important. The light required for sign detection and legibility increases geometrically with the age of the viewer. Here is an example of a reflectivity test. Notice the stop sign at the right in daytime. This is the same location at night. The sign that you see is not the original sign, but a test panel that was placed below the permanent stop sign. The permanent sign has lost all of its reflectivity and is completely invisible at night. As you saw in the video, traffic sign inventory is essential to a well-managed traffic engineering program. A good sign inventory would include the location of the sign and the direction in which the sign faces. The information collected should give a thorough inventory for sign installation and maintenance. 1. The type of sign by the categories defined in the MUTCD. 2. An assessment of the physical and functional condition of the sign. 3. The message that is on the sign face. 4. Installation date. And 5. Identification of the background and legend materials. Should all be a part of the inventory. The sign support type and condition should also be noted. Now you can see here an example of an inventory form developed by one jurisdiction. Inventory numbers or serial numbers are sometimes used on signs. When they are used, the numbers are placed on the back of the panel so that the numbers don't interfere with the sign's message. The primary rules of signs are that 1. They should be simple, and 2. They must be standard. Working in conjunction with signs to guide motorists are roadway marking and delineation. Marking and delineation guide motorists either positively or negatively. Positive guidance shows where the driver should be on the roadway. An example of positive guidance are lane markings. Negative guidance, on the other hand, tells drivers where they shouldn't be. For example, hazard markers. The manual on uniform traffic control devices contains detailed guidance on the use of pavement markings and other delineation. Of course, the Traffic Control Devices Handbook, the companion document to MUTCD, gives implementation guidelines for MUTCD. Pavement markings, raised pavement markings, post-mounted delineated markers, object markers, and various special devices are all considered to be marking and delineation. Like signs, pavement marking colors have standards. Each color conveys a special meaning. White pavement markings are used to delineate the separation of traffic lanes where all traffic is flowing in the same direction, and crosswalks. Yellow pavement markings separate traffic flowing in opposite directions. Red pavement markings are prohibitors. The center line and edge lines are longitudinal lines. The standard width of these lines is 4 to 6 inches. White solid lines restrict crossing. Yellow solid lines prohibit crossing. But yellow lines also show the presence of opposing traffic. So on freeways, the left edge line is yellow and the right edge is white. shoulder markings, words and symbols on the pavement, stop lines, and crosswalks are transverse pavement markings. Designs for these markings are found in the metric edition of standard alphabets. Transverse pavement markings such as stop bars and crosswalks must be much wider than longitudinal lines so that drivers can see them well enough from the driver's angle of viewing. A variety of materials are available for pavement markings. Here you see a list of these materials. Paint is one of the cheapest but not always the most cost-effective materials to use. While paint has a relatively short service life, its low cost and easy application sometimes offset its short life. Pavement marking materials must have glass beads added to them to provide the necessary retroreflectivity for nighttime visibility. Pavement markings that are no longer in use must be removed for safety. A change in roadway alignment or a change in line position requires that the old lines are removed. Now, here you see a situation where the double set of lines confuses drivers. Night is particularly dangerous because a driver could easily follow the old markings into the barrier. The effectiveness of delineation devices, whether they are painted markings, plastic markings, raised markers, or post-mounted devices, depends entirely on its visibility. Raised pavement markers can be used as a substitute for lane lines, and they can also be used to supplement lane lines. They have excellent nighttime visibility, and they have the added benefit of an audible warning when they are crossed. In areas where it snows, snow plows can easily remove markers as they plow. So in these areas, snow plowable markers are needed. A number of such markers are available. In one of them, the reflective lens is protected by hardened steel ramps and are frequently recessed into a milled cut in the pavement. The MUTCD specifies the proper patterns of raised markers to simulate pavement lines. Here, you see the required patterns for raised markers when they supplement pavement lines. Post-mounted delineators are another positive guidance delineation device. No matter which of the variety of post-mounted delineators is used, it must meet the requirements you see here. Reflective sheeting dots and strips can be used to satisfy the basic requirements. The MUTCD states that the delineator color shall conform to the edge line color. So, if the delineator is adjacent to a yellow edge line, it would be amber. Right-sided mounted delineators are always crystal. The MUTCD also states that post-mounted delineators shall be placed on the right side of expressways and at least on one side of ramps. The MUTCD also says that delineator posts should be located 2 to 6 feet outside the edge of the shoulder or curb face and should be about 4 feet above the road. When a hazard exists on the paved roadway surface, the delineator should guide the motorist safely by the hazard. So that the reflective element won't be a flying hazard, it should be firmly attached to the post. A washer should be used so that the reflective element will remain on the post when it is struck. The use of post-mounted delineation has been studied in depth. The major finding of these studies are: accidents are not reduced on tangent sections, but significant accident reduction occurs for curves over 5 degrees, for restricted width structures, and for rural intersections. Post-mounted delineators are particularly effective in showing the roadway path on combination crest vertical and horizontal curves. If the pavement at intersections is not adequately marked, post-mounted delineators can help. The number of accidents involving barriers could be reduced by placing retroreflectors on them. The retroreflectors should be mounted on the post and not on the face of the rail. The object marker is used to call attention to a hazard on or near the pavement surface. This object marker points out where the driver should not drive. so the object is a negative delineator. Upstream ends of longitudinal barriers, as you see here, are one of the situations requiring a hazard marker. When traffic can pass on either side of the hazard, the center object marker, shown here, is often used. For center markers, a combination pattern is used. The nose of crash cushions must be well delineated. Special situations require special delineation devices. We'll look at some of these. A lane closing must be clearly communicated to the public. The arrow board is an effective way of doing this, especially on high-speed roads. The arrow board should be located in the closed lane just beyond the cone line. An alternate placement, but one which is not as effective, is on the shoulder at the point where the cone line encroaches on the through traffic lane. Another special situation is created in many parts of the country by wildlife crossing the highway. Fencing doesn't usually prevent deer from crossing roads, so other means must be used. The special delineator used in these areas redirects the approaching headlights transversely away from the roadway. An illusion of motion is created that frightens deer away. Rumble devices are not considered to be traffic control devices by the MUTCD. They very effectively warn drivers of an approaching hazardous area or situation. Whether or not to use rumble devices must be carefully considered. 4 specific conditions influence the effect rumble devices have and need to be taken into account. Rumble devices shouldn't be used where they will cause problems. Shoulder termination is a serious situation that needs high delineation so that drivers are not surprised by the absence of shoulders. Discontinuous shoulders severely limit the use of the shoulder for temporary traffic movement. Narrow bridges are also a special problem. Post-mounted delineators, hazard markers, no passing zones, rumble devices, and special markings all help supplement warning signs at narrow bridges. Removal of old pavement markings frequently creates delineation problems because glass beads in the paint still provide retroreflectivity at night. Painting over old markings is not acceptable. Drivers would be confused if this were done, but removal of paint lines costs more than $1 a foot for a 4-inch line. Burning, grinding, or sandblasting all have one common problem. A shadow line is always left. The line is not too noticeable in daylight, but at night, under headlights, the remaining dark line could easily be confused with a painted stripe. One of the most successful methods is burning using oxygen. The partially melted asphalt is brushed over the aggregate before it cools, and the shadow line is not a problem. One of the most powerful delineators is the pavement itself. Drivers are uncomfortable when they cross joints or differing pavement types. Rehabilitation designs need to correct differences in the feel of the road to the driver. When these differences exist, positive delineation devices should overcome the negative effects of the pavement. Resurfaced roads should be marked before they're opened. Unmarked roads are dangerous. A full complement of pavement markings should be in place at the close of each day's work. In fact, no markings can be more hazardous than conflicting markings. Particularly dangerous are unmarked rural sections with no external sources of light. Pavement markings must be seen to be effective. Each of these factors influence the visibility of markings, and markings that appear adequate during the day might not have adequate reflectivity at night. Nighttime reviews need to be made to be sure that visibility is adequate. Nighttime visibility is dependent on reflectorization. Reflectorization is achieved by adding glass spheres or beads to the surface of pavement marking material or to the material itself. The glass spheres are the retroreflective devices. Usually, the pavement marking material film is very thin, and the glass beads must be exposed to be effective. So many glass beads are lost through tire wear long before the marking is worn away. When reflectivity is gone, the marking must be replaced. Pavement markings deteriorate very quickly when they are driven on, so edge lines should not be placed where cars will regularly travel. For travel lanes narrower than 11 feet, placement of the edge line on the shoulder side of the shoulder joint will add slightly to the effective lane width. But when the lines are placed there, drivers drive on the shoulder joint, speeding the deterioration of the joint. Edge lines shouldn't be placed directly on the shoulder joint. Edge lines alone are not enough to define the roadway under certain geometric situations. In this picture, the driver approaching the crest vertical curve would not know where the road goes beyond the crest. The edge line disappears at the crest. Post-mounted delineators would be helpful to indicate roadway geometry. Delineation devices should be inspected in all types of conditions to evaluate visibility. Here's a simple procedure to follow to evaluate the reflectivity of markings at night. All markings should be visible for at least 2 seconds in all kinds of conditions. Delineation devices contribute significantly to the ways we can communicate to drivers. The types of devices available, the conditions in which they should be used, what affects their visibility, and how to evaluate their effectiveness are all part of the knowledge that helps us use delineation devices successfully. The Texas Department of Highways and Public Transportation has produced a videotape that will show us how markings, signs, and signals form a communication system to drivers. We'll close this session with that tape.